请启穿麦孔。
Hello, testing, 1, 2. Okay, so let's start first. Later we'll talk about project again. All right. So continue with this drive chapter here. We're learning a lot of calculation, basically, a lot of techniques. Maybe you could ask me whether these techniques you must use or not. I would say anything that makes you to calculate the right solution, that's fine. But maybe perhaps this technique is somewhere where you can start, or sometimes helps you to do the least work. Okay, do the least work. Because these are based on people's experience. But you may find new ways that's possible. Right. Okay. So let's continue with trigonometric substitution here. So next, we'll integrate this kind of integrand, which is a product of cos and sine in different periods. Okay. So if you are multiplying sine and cos in different period, or sine and sine in different period, for example, part B or part C, you multiply, you take product of cos in different periods. Okay, then we can write it solely in the sum of sine or cosine. Okay, because we know how to integrate sine and cosine. Okay, with period, just use substitution. Okay. Right. So let's do the first one. Okay, so first question was asking you to integrate sine 2x and cos 3x. Okay, so this is a product of sine and cosine in different period. So we just use the part A, okay, to transform it to some function solely in sine and cosine, but we need to take the sum. Okay. So, half of sine and plus sine x. Okay, yes. Okay, so this is by A. We put A here, right? Okay, so how to integrate this sum here? Because integral is linear. Okay, so I can pull the scalar out. I also can calculate the sum separately. And then add them up. Okay, so I think I need to substitute my m and n here, right? Okay, so my m here is 2, my n here is 3. Okay, so I need to transform it. 2 plus 3, and then here is 2 minus 3. Okay, so in this case, become 5 for m plus n, m plus n, and then m minus n is minus 2. Okay, so sine is an odd function, right? So sine minus x become negative sine x. And so you can bring the minus sign off. Okay, so what do you do next? The second step is linearity. Okay, third step is odd function. Then you can use your substitution. U equals to 5x and then du equals to 5 dx, and so become integrate sine u dx become du over 5, right? And then minus, so integrating sine x, we get negative cos x. Okay, so altogether we get negative cos u over 5 plus cos x, and then substitute back your cos, substitute back your u, negative cos 5x over 5 plus cos x, and then plus c. So there's a constant. C can be outside the method. Okay, so far, any question? Okay. So the new stuff here is just the trigger substitution. The rest is whatever we learned before. Any questions so far? Straightforward? Or any calculation error? Okay. Can we proceed? Okay. So let's go to the next one. So let's say this m and n is a positive integer. Okay, any positive integer, so meaning like 1, 2, 3, 4, or 100, so on, right? Okay, show that if m is not equals to n, this thing actually is 0. Okay, very easy. If m equals to n, then this thing is 5. So what's this thing? So sine mx and sine nx. Okay, so maybe you could have two functions multiplied together, right? So your sine must be something like this. Okay, so what's the business with mx and nx here? So the period could change. Yeah, so maybe the period could change. So maybe it looks something like, maybe one of them is wider than this, or smaller. Okay. So you take the product of these two functions. So what does it mean by products? So basically you just slice it in one line and then take the product, multiply the two y value together, right? So this is your new function. Okay, after you multiply, it becomes a new function. Okay, makes sense? Yes. So for example, at this point, right, at the other point, let's say at this red point here, what's the value of the product? What's the value of it? You have something from the purple graph, something from the green graph, multiply them together, what do you get? What do you get? What's this line? As I say, right, y equals to what? X axis, y equals to y equals to 0. So something times 0, you get 0. Okay, so at this point, your new function is 0. Okay, so how do you imagine what's the integral here? Okay, then this question tells you that if their period is different, okay, their period is different, then the area will cancel out, top and bottom area will become 0. So if it's not in phase, the area of integral is 0. Top and bottom will cancel. But if n equals to n, so meaning this green line here will match with the purple line. Then you have some non-trivial area. Okay. So this is what we're gonna prove. All right. So similarly, this is a product of a trigo with different period, right? So you can use the trigo identity. So in particular, which one we can use, A, B, or C? Which one can we use? A, B, or C? Choose one from the three answer. Yuhen, can you choose A, B, or C? B. Okay, so you can choose B. Right. Oh, do it. You can start from calculate because this step is kind of long. You can try calculate with me together. See if we get the same thing or not. Okay, so if we use B, what do we get? We get cos mn plus x. Mn plus n times x minus cos n minus n x dx. Okay, and then I pull the half out. All right, so what should we do here? What do you think, Felicia? How can we continue from here? How can we continue? After we already write it in terms of cos already. But inside the period is not x, right? So we can do substitution. Okay, so we do substitution. Okay, so let's do substitution here. So there are different substitution you want to do, right? M plus n and n minus n. And then du is m plus n, yes. And dv is m minus n. Okay, so after you do substitution, right, your integration limit will change as well. Okay, so your integration limit will change as well. So if x equals to pi, then u will become m plus n pi. When x equals to minus pi, u become minus m plus n pi. Okay, and then when x equals to when what else? Yeah, sure. So then v over v just become m minus n pi when x is pi, and v becomes minus m plus n pi when x is minus pi. Okay, so just do the substitution rule. Very routine work. Yeah. Okay. So we just substitute everything back, which we get. Let's see. Why do I get a minus sign here? Oh, I think I miss a minus sign when I do substitution. B got minus sign. Yeah, B got a minus sign. So please take notes here. B got a minus sign. Okay, so let's continue. Use a smaller one. It's too small, a bit small. Small times that one. This one smaller a bit. Okay, so cos u over m plus n du minus n minus m pi m plus n pi cos v over m minus n. Need bracket? Yeah, need a bracket. Let's see, do I have a bracket here? Okay, I pulled it out. Sure. Okay, so in this case here, just do the usual integration. Okay, right until this stage, did you see any problems or not? Did you see any problems after you write down this step here? Do you see any problem here? Any problem? I can see until this stage. One over m minus n. You need to be careful with the difference. Moreover, the difference happen in the denominator. What you don't want in the denominator? Yeah? 0, right? Can m minus n be 0? No? Cannot be, but when can it be 0? When m equals to n. Okay, so in this case, actually we should assume m not equals to n case first. Okay, we should assume m not equals to n case first. Only we can proceed in this way. Okay, so later we will treat m equals to n case alone. Okay, we cannot do this kind of substitution. So some things will go wrong when you do substitution. Okay or not? Okay, so let's finish compute this. Anyone know how to compute this thing? So what does sine do when you take multiple of pi? Because n plus n is just some integer, and n minus n also integer. So sine, okay, maybe I need to write here. Sine n pi equals 0 for n in Z. Okay. If you still remember the sine graph here, so here is 0, here is pi, here is 2 pi. Okay, so you can get all the 0 at the multiple of pi. Okay. So you get 0 minus 0, you get 0. Everything becomes 0. Make sense? Question? Any question? Is everyone clear with this part here? This assumption. Sine n pi equals 0 for all n in pi. Okay. Or should I write down the intermediate step here? So for example, you should get negative half of 1 over m plus n of sine m plus n pi minus sine of minus m plus n pi, and then so you can write it down. Okay, so this two terms here becomes okay. Okay, so how about m when m equals to n? Okay, what happens when m equals to n? So if m equals to n, right, these two terms actually is the same term. Okay, so it becomes sine square mx. Okay, it become combined. Okay, we can combine them. So let's write it down. Okay. So for m equals to n case, our integral become easier. In particular, we get sine square mx dx. Okay. Okay. So from Wednesday, right? How do we reduce this? How do we reduce the power of square here? How do we reduce? What formula we can use? Trigo substitution. What sort of trigo substitution we can use here? What sort of substitution we can use? Hmm? What kind of substitution? Sine square x can be related to what? Say again. 1 minus 2 cos square x? Ah, wait. What? You mean cos square x? Just cos square x? But then you haven't do any reduction, right? You just turn one of the square to the other square. So it's not quite useful here. So we want a formula that can reduce the power. We want to remove the power. Okay, so that we can go back to the usual sine x and cos x to do integration. Any other? Maybe the answer lie in double angle formula. Try and get your table out, the Trigo formula. What? Half minus half cos 2x then equals to sine square x, like that. Yeah, I think this looks right. Let's see, let's rewrite this. So cos 2x equals to 2 sine x 1 minus. I think this looks right. Okay, yeah, so we're gonna use this. Okay, so this will bring your power down. Okay, power down. Although we swap to cos, but we know how to integrate cos. Okay, so this will help us to reduce the power. Okay, so in this case here, I will do some factorization. Factorize negative half, okay, such that I get cos 2mx minus 1 x. Okay, but then do you still remember how to integrate this term here, cos 2mx? Cos is an even function, but then this minus pi and pi is symmetry around y-axis or 0. So this integral should be 0. Okay? Because you are integrating an even function on a symmetric interval across 0. Okay? So what you really get is just half of minus pi to pi ax. Okay? So here, maybe I'll say that cos 2 pi x is even and minus pi to pi is symmetric. Uh, 0 cross. Okay. So what's the last integral here? So this is just half of x from minus pi to pi. Okay, so what do you get? 2 pi over, which is? Okay, so now can you see like how this answer come from? Okay. So if it is in different phase, you integrate the sine function, and then your sine function evaluate multiple of pi, so you get 0. But if n equals to n, you are just integrating a constant one function, a minus pi. Also as a half contribution from your double angle formula. Okay, makes sense? This identity, right, is very useful for your next semester class, calculus 2, where you do something called a Fourier series, and you will see this kind of combination coming up. Okay, so far any question? Any questions so far? No. Okay, good. Right. So 7.14 is a similar flavor here. So maybe let's look at 7.14 first. M and N again is positive integer, but The phase here is a bit different. So the phase here becomes pi m over l. Then the period here becomes pi m over l. And then the pi for the integral limit here becomes l. And arbitrary l. But notice that the symmetry across the zero is still the same. Minus l to l. That's all same distance from zero. So can you see that this is our 7.13 is just a special case of this. But when L equals to pi, here pi and pi can cancel, it's just mx. Okay, so this is a general condition, general situation, and more general situation. Maybe I can let you calculate yourself, but do you want to guess the answer? Do you want to guess the answer? Want to guess the answer? Actually, whatever you do just now works, right? It's just something inside the period changes, and then the minus pi and pi become L, minus L and L. So do you want to guess what's the solution here? Conjecture, that is the technical word we use. Okay, so similarly, we'll guess that it's split into two cases. Okay, so I guess the cases for you already. Do you want to guess what's the answer? Felicia, guess. Based on what we know just now. When m not equals to n, what do you get? Based on 7.13. Huh? 0, good. But n equals to n, eh? Yes. Okay. So you should compute to this answer. Okay, use the same method and then do the calculation. Okay, make sense? Okay. So I mean, one technique in one skill set you want to learn from mathematics is to guess correctly. Okay? After you guess, you need to show it. Okay, you need to do calculation. Okay, this is what we call conjecture. Okay, you need to guess. Yeah, for the Chinese student, maybe you know something called 猜想. You know 猜想? Don't know. It's conjecture. So you need to 猜, right? Guess. Right? You need to guess. Okay. Guess the solution. And then check when it meets your expectation. All right. Let's continue then. So now we're gonna do a slightly different flavor. Instead of integrating sine and cos, now we do tangent. So what does it mean by tangent? Tangent is just taking quotient, right? Okay, quotient of sine and cos. Okay, so instead of products, now we deal with quotient now. Okay, so what sort of substitution is useful here? Maybe I'll do this one and then I'll let you try the next one. Okay, so for this one here, it's not too hard. Okay, we just try the the straightforward reduction here. Okay, because there are sine cos, right? So we try to reduce one to the another, hoping that we can cancel out something. Okay, hope that we can cancel out something. Okay, so let's use our favorite trigo identity here. See if we can make something out of it. Okay. So last time, what did we say last time? So when we see sine and cos, right? Whenever we want to do substitution, okay, it is good that we have another trigo function with us, because so let's try some experiment. Because let's say if I want to let u equals to cos x, okay, du will definitely produce another trigo function for you. Okay, so if sine x is around, then our substitution will work. Okay, so this is a very perfect situation that you can use substitution. Okay, so if we do substitution rule, we get 1 minus u square, everything square, over u to the power 5. And then sine x dx become du. Yeah. Yeah. If sine is not around, then substitution could be hard. Okay, then what do you do next? These are just polynomial, right? So you just expand it. And then what do? You simplify it. Oh, the minus sign. Is there a minus sign? Yeah. So I miss a minus sign here. Uh, you differentiate cos, you get cos x, you get negative sign x. So here got negative, here got negative. So altogether you get 1 over 4 u to the 4 minus 1 over u square minus ln absolute value of u plus c. So you get 1 over 4 secant to the power 4x minus secant to the square x minus ln to the cos x. Okay. Any question so far? It's straightforward. Okay. Integrating polynomial. Okay, so you add the power and then you divide by the power. Add power by 1. Okay. So if this is okay, so how about you try this? Can I give you 2 minutes? Try if this works or not. Morning. Anyone successfully tried something? How run? Did you get something? No? What did you try? 还没事? Okay. About the others, what did you try? You tried? What did you do? What did you say? Do you know how to say? No, I mean like just read your step. Do you like see this as cos to the 4x over sine to the 4x, or you do this and then what do you do next? I mean like what identity you use or what substitution you use. Which one? Which one you don't know how to say in English? Transformation. So you let what? What do you let? Let what equal to what? Huh? I mean like what formula you use first? Did you use any formula? What formula? No, you don't use formula, but you can calculate. Okay, so you use, so basically, so you use cotangent square x equals to cosecant square x minus 1. Okay. Everyone know how to get this cotangent cosecant condition here. So this is also rooted from sine square x plus cos square x equals to 1. Okay, but you need to divide everything by sine. Okay, you need to divide everything by sine square. Okay, so that this term here is the cotangent, right? Cos over sine. And then 1 over sine square x become cosecant. Okay? And then sine square x over sine square x is 1. Okay, so still the same formula you need to remember, just say some trick. Okay, divide by sine. So similarly, you can divide by cos to get another relation. Okay, so you do substitution using this. Okay, so actually this is not very helpful. We just straight away go in using this formula here. Okay. Wait. Do you substitute both? Do you substitute like all the way in? Okay, if you substitute all the way in, what happens here is you're gonna produce another trigo function with power 4 again. Okay, which is even more complicated. Previously, you just need to deal with 1. Now you need to deal with 1 plus several terms. That's not very useful. So actually, we will just do partial substitution here. Okay, so we just do partial substitution. Keep one of the cotangent there. Okay. Maybe you might ask, why do we do this? Why do we do this? So what's the relation between cotangent and cosecant? Okay, this is the thing that you need to keep in mind. Okay, or keep the table beside you. Okay, keep the table beside you. So what's the table you need to keep here? So basically, you need to keep this derivative relation here. So there's a derivative relation here. So if you differentiate cotangent x, you will get minus cosecant squared. So what does this mean here? This means if you integrate minus cosecant square x, you get cotangent. Relationship. All right. So what should we do next? Maybe let's split out the terms. Let's split out the term first. Because we're gonna treat them differently. Okay, this is one term, and then the other is one term. Okay, so can you see some trick we can use here? Okay, there's a cotangent with cosecant here, right? So it's like sine and x. So you can think of this kind of relation like differentiate one of the trigo to the other trigo, and then they appear together. Yes, use substitution. Because a derivative appears here. So use substitution. Very good. Okay, so you abstract the idea of sine and cos because they are just derivative of each other. So we're gonna use substitution for this term here. Missing one dx. Okay, so what's the substitution we're gonna make? So u equals to cotangent x, and then du is minus cosecant square x dx. Okay, so this term here, the first term here will become integrate minus u square du. Okay, but how about cotangent square x dx? Okay. I'm not sure what way you use. What I'm gonna use is I'm gonna use again the formula. Okay, become this. Maybe you could say, hey, I thought just now you say that we don't want to keep the same power, right? But not that we have this relation here. We know how to integrate cosecant square. Maybe we don't know how to integrate cotangent square. Maybe you can get a formula, but not sure if we had it before or not. But you definitely can derive from here. Okay, so let's continue this calculation. 3 plus tangent x, and then plus x, which is minus cotangent q. Okay, so we should use this relation here. And because you integrate minus cosecant x dx equals to integrating d over dx tangent x dx, which is by definition is the antiderivative, which is okay, perhaps you plus some constant. Okay, any question so far? Question? So make sure you can follow what I say. So if you're gonna digest, you can go back and digest, but make sure you can follow what I say so that you go back, when you do revision, you still remember what's the step. Okay, so far. Any question? Any questions so far? or any calculation error? Okay. Okay. Okay, right. So now you can see that this is an upgrade level of like the relation between sine and cos. So we use this cotangent and secant here. So next, how about secant and tangent x? Okay, so there are some uh, derivative you want to keep in mind, in this case. So for example, what's the derivative relation between tangent x and secant x? Okay, it becomes secant square x. And what's the relation between secant x and tangent x after you differentiate secant x? So maybe you get secant x tangent x like that. Okay, so these will help you to decide what sort of substitution you want to do. Okay, uh, any others? So for example, tangent square x equals to secant square x minus 1. Okay, this one, how do you get it from? Like what I said just now, right? This is from this master formula here. So this master formula actually is describing a unit circle. Right? This is describing a unit circle. And something square plus something square equal to 1. Okay. So actually this represent a circle. Okay, so this point is sine x and cos x. Okay, so this master formula actually is a unit circle. Okay or not? Right. So to get tangent square x, what do? You divide this master formula by cos square x. Just now we divide by sine square x. Now we divide by cos square x. Then we take the version for tangent square x. Okay, so in this case here, what we will do was you are trying to reduce the power as soon as possible, right? So we're gonna reduce it using formula here, secant square x uh, mm, minus 1 and tangent x dx. Okay, and what we get is secant cube x tangent x dx plus integrate tangent x dx. Okay, so maybe you said that, I thought you said you want to reduce the power, but the power is still 3. But this is at the expense of creating the tangent x. Okay, so if you have tangent x and secant x together, then this is something related to the derivative of secant x. So again, you have your function with your derivative together. This is a nice place where you can do some. And this is a nice place where you can do substitution. Okay, when the derivative and the function itself appear together, this is a nice place you can do substitution. Okay, so what sort of substitution we're gonna do? So let u equals to secant x, and then du is secant x tangent x. Yes. Okay, so what do you get? You get integrating u squared of du. So very simple, polynomial. Okay, how about tangent x? Have we integrated tangent x before? Have we integrated tangent x before? Feel like we do it before. Have we integrated tangent x before? What's a nice way to integrate tangent x? You can write tangent x as sine x over cos x, right? Okay, so you can see that the function appear together with x derivative is also a nice place where you can do substitution. So you substitute what? Substitute cos x. Okay. So if you substitute cos x, EV you will get negative sine sine x dx. Okay, so on one side you get u cubed to the 3 over 3, and then on the other side you get 1 over v minus 1 over v, wait, minus 1 over v d dx dv. Okay, is that right? Did I miss anything? Hey, I think I did something wrong or not? Did I? Sorry? Which one? Which one? For tangent x, or should be or should be a secant. Okay, 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 okay. Okay, then it's easier then. Then it's easier, right? We don't need to do this kind of substitution. Yeah. Okay. So I think I missed something. So you see, you are if you are missing some trigo, right? Things could be very different, because if you are just integrating secant tangent x, right? This is what we know already. Okay, if we integrate this, we immediately get secant x. Okay, because this is the antiderivative of secant x tangent x. Okay, so this is just secant cube x over 3 plus secant x like that. Do I have sign problem here? Yeah, I got a sign problem. So this sign need to bring down. Okay, so make sure you put the sign right. Okay, question? Any question? Any question so far? Okay, no question. How about we try one more question before we take a break? Okay, I'll let you try this question. Let's try one more and then before we break. Again, I here got the function with x derivative appear together, but now the power is even. Okay, so let's see what you can play around with this. Okay, so what do you do? Anyone finish? Calculate this. Manage to bring the power down or not? Okay, very similar formula we're gonna use. Okay, basically, mm, we need we need the secant square x again equals to tangent square x plus 1. Okay. Okay, so let's see what this can do for us. So try. Okay, we just try first. Okay. So if we do this, what we will get is tangent 6x secant square x times tangent square x is 1 dx. 1. Then we get tangent to the 8x secant square x dx plus tangent to the 6 x dx. Okay. So it might be weird that we push the power of the secant to the power of tangent. Okay, but this secant square here is very useful. Okay, if you still remember just now we see this square popping out somewhere. Okay, which is the derivative of tangent x. Tangent x. Okay. So again, it's the case of a function appear together with its derivative. Okay, so there's a nice substitution you can do. So if you let um, u equals to tangent x, then the derivative of tangent x is secant square. Okay, so in this case here, what do you get? You just get u to the 8 du plus u to the 6 du. Like that. Then this is just a nice ornament. Okay, very nice. Which is the tangent 9x over 9 plus tangent 7x over 7 plus c. Okay or not? Yeah. Any question so far? Okay. So here you will substitute u equals to tangent x. Before, if the secant appear like in the odd manner, you can use secant x. Okay, so this is the trick you play. So secant is for odd, tangent is for square. If you want to remember this way. Okay, so there's a general strategy here. Okay, so if you are integrating the product of product of m product of sine and n product of sine together. So here is the general strategy. If one of them is odd, okay, if one of them is odd, then you just do the sine square x plus cos square x equal to 1 substitution. Then you substitute either sine or cos, depend on which one is odd. So if cosine is odd, you substitute sine. If sine is odd, you substitute cos. But when both of them is even, we will try to push them into a double angle formula. Okay, double angle formula here, so that we can reduce the power of sine. Okay, so use the double angle formula. Okay, because if it is appearing odd, right, there's an extra cost of sine appearing. So that's the good place where you can do substitution. Similarly, if you have m product of tangent or n product of secant here, so if secant power of secant is given, so just now we conclude that we want to substitute tangent x. If the tangent is odd, then we will use substitution of secant. Okay. If not, you no need to memorize these. Let me tell you, no need to memorize. I don't even look at these also. You just try until it works. There's only two ways to try. I mean, you see. So this is the same substitution we're doing tangent x equals to secant square x minus 1. Okay, then you try out, there's only two ways, right? Either you want to substitute tangent x or either you substitute secant x. One of them must work. Okay, just try. But the most importantly is you need to keep your table of derivative beside you. Okay, if you cannot remember, you should keep this derivative relation beside you. Okay, you should keep this beside you. Okay, so that you are sensitive, okay, to the substitution, the derivative. Okay, keep this beside you. Okay, one of them must work. Actually, when I prepare the notes, I don't even follow the strategy. Maybe you can just do this substitution. You also get the answer. Okay, I don't use the tangent square x equals square. I transform this back to sine and cos. The solution is not long. It's still okay. Yeah, still works. So don't just memorize strategy. Okay, strategy could help you, but there are also other alternatives. Okay, so far any question? No? Okay, if no question, we'll take a break. So later when I take the attendance, right, if you already confirm your groups, you let me know. Okay, if not, keep finding groups. Next week must confirm your group. Okay, and then next week we'll start decide. You need to tell me your project topics. Okay, decide with your group member. How many? At most 4. At most 4. Okay, you could be one person, but at most 4. Okay, one person you need to do around 5 minutes. If there are more, then each of you just do 3 minutes. Okay, so solo could do more. So let's take a break first. We will resume 10:17. Hey.
Yeah.
I understand. Which one? Cosecant?
Cosecant.
Yeah, cosecant. You mean what is cosecant?
Yeah.
Oh, okay. So cosecant. So cosecant by definition is sine. Yeah.
No, it's
What do you
not
mean?
the same symbol like
What do you mean? Oh. You mean the full word is the full word is this. Yeah, this is the short form.
my bad.
Yeah. Okay. So the secant also the full word is like
Okay.
yeah.
Sometimes you write full words.
Yes, sometimes I read full word. But whenever I read, I will read the full word.
Okay.
Yeah.
Okay.
上面有个东西没有
对
第一期，
一题，就是之前的，
就是
刚刚
这个
哦，这个啊呀，
这这里，你看
哦，这里是 integrate 2个 function，
这两个都是哦，
没有，这个是 even，这个
不是
错是 even，
那个一本对一本啊，
对啊，错是 even，对啊，
是有点对，
哎，有想象啊，喂，给我想象，啊，
就寄回去
我再归回去。
，integrate 所以变成sin
啊，对，after inter，哎，但是也不可以这样解释啊，但是等我想想，对，如果一个，哎，对哦，我讲，对哦，等一下我看一下啊， 等下给我想一下啊，发生什么事情啊？这个方程，并不是没有。对对对对对，
这不你直接
我看一下，
哎，其实不用到这边，
或者说，等一下给我想一下，出现什么事情？shit，对，那 cos 是应该对啊，我觉得我知道发生什么事情了，应该是 OK，应该不可以用那个 cos and od 来解释，因为
这个是不是要先把它们拆开？是这个意思吗？如果出现几个，可以把它拆开。
OK，确实是两倍，确实是两倍，但是这一边应该是零来的。OK，应该少讲了一个东西，应该是要讲一下零到派
哦，要注意到
这个东西应该是零，
那个就刚好抵消掉，是不是？
上跟下比较，
如果是3/4派的负4/3就抵，
就是
就是这个，就是这个，在这个地方
就抵消不了，
或者在这个就抵消掉。
这个
啊，所以就是刚好是凑巧的。
对，这个才是你刚才讲，因为这个会跑回 sin 嘛，还是 over 这个，所以这个是在那个也是 interval，也是在 multiple of pi 之间的话就零，因为是上面这个 part 跟下面那个 part，所以我刚才少讲了这个要讲
所以这个是不是对
啊，这个
这个
就是我们假设 m 等于 n，因为之前算的是 m 不等于 n 的情况
对，是我说什么到这里？
啊，因为你就拿两个 sin mx 乘在一起啊，
那我直接如果带这边不是移不出来，就是这个，就是
没事，
就是从这边可以直接到这边，
一样的，
就带这里是
啊也可以啊，嗯、
这样不是
啊，也可
快
以啊，也是啊，因为这个是它的 formula 来的
应该转一遍那个。
啊，确实啊，这个是比较 general 的，对于这个比较 general，因为这个是两倍一样的东西，但是那个是有相差
啊，
耶
对，
，OK，好，OK，so for those who are here, I will take attendance first. 雅婷，你有呢？何雅婷，OK，陈凡，OK，you going solo on your project, 陈凡？Are you finding group mate or alone? Okay, so if you are a group project, right? You need to find a group leader. So decide among yourself a group leader. I will take notes. We here or not? Not here. Hong Liang, do you have group mate? Do alone? Okay. See her. I think I saw see her just now. See her, yeah. Yeah. So have you found your group? Haven't? Okay. So please let me know next week. 乐天. Okay. Did you find your group? You already found your group? Who are with you? Who is your group member? You want to come here? Have you found your group for your project? Not yet. Oh, not yet. Okay. So please decide soon. Ray Yang. Okay. Did you find your group member? Not yet. Okay. Please find. 若石. Okay. You? No. You two want to be a group? Two of you want to be a group? You still discussing? Okay. Siman. Okay. Have you decided with who? 范成汉，范泽汉哈，泽汉 here together. Okay, only two of you, or you still finding group mate? You fix only two. Okay, so I will fix. So you are group 3 now. Okay. Yinan. Yinan. Okay. Have you found your group? Not yet. Okay, please go and find ya. Yu Tao. Yu Tao here. Chen Yu Tao. Okay. You? Have you fixed your group? Yes. With who? 1, 2, 3, 4. Okay. Ngam, 1, 2, 3, 4. So Chen Yu Tao. And then who's the rest? Tao Rang, right? And then I know Yiling. The Yiling. Jing Jingyi. Okay. Jingyi. Okay. Good. Yize. Yize, have you found your group? Who? Which one? 3? Who is the 3? You 3. You 3. 3 of you. Already fixed? Or you still finding group mate? 已经定了吗？还是还要再找多一个？啊 ？Only 3 of you，3个吧？应该是最多4个，还要再找吗？你们再讨论？再讨论还是已经定？再讨论一下，OK。丽文，OK，Have you found your group? Margaret, Brandon, 3 of you. Which one? Who? Robinson. Okay, good. So 1, 2, 3, 4, 5. Group 5. So Lee Wen, and then Miao Pinson. Aaron. Not Aaron. Margaret. And then Brandon. Where's Brandon? Okay, good. Rian. Rian. Have you found a group? Who? Le Tian. 2 of you only. Still want to find more? 4 of you. Okay, good. So Rian. So group 6, Rian. And then who is the one Le Tian, huh? Le Tian. Okay. Rian, Le Tian. And then Desmond and Tommy, huh? 4 of you. Okay. Le Tian. Okay, 6 group are done. Jia Lai. You found a group? You want to do alone? Okay. Okay, maybe I'll continue again next hour. Okay, give you time to think about it some more. All right. So just now Li Wen point out a very good point here. So this cancellation is not because it is even. It's because after you split into the even part, a single part from 0 to pi is a 0 is a 0. Then you calculate to 0 because the area above the graph and below the graph is at pi over. Okay, or you do the calculation. Okay, if you do the calculation, you get sine 2 pi x over 2 pi x. Evaluate to 0 to pi. Again, we are evaluating as a multiple of pi. So that's why it's 0. Okay, so they cancel out. Okay, it's not because of even they cancel out. It's because if even you can split to 0 to pi, and then if you look at the integral of 0 to pi, it is 2. Okay, so let's continue. We'll continue with this trigonometric substitution. Okay, so what's this? What's the business of this? What's the rationality of this? Okay, so where these things come from? So where are these things come from? So how to read this table here? So first expression, what's the expression it means here? So the expression here is the expression in the integrand. Okay, so meaning you want to integrate this kind of function, square root of difference of square or sum of square, another difference of square. Okay, you might think that, is it a big deal of swapping x square and a square? So what's the relation of a square, x square here? A here actually is a constant. Okay, a is fixed already. X is the variable. Okay, you want to integrate with respect to the x. Okay, with respect to x direction. Okay, so that's why there's a difference here. Okay, either you take constant minus the variable, or you take variable minus the constant. Okay, so why do we do this kind of substitution? So can you think of any relation between angle and this square here? What's the relation? Right angle, triangle. Okay, so you should remember that whenever we talk about sine and cos, right, this tangent number, right, is like the opposite side over the adjacent side, or the adjacent over the opposite, or hypotenuse, right? Okay, so if you draw out the substitution, for example, x equals to a sine x, right? This means what? Sine theta equals to x over a. Okay, so what this means is you have a right angle triangle with the angle theta such that the opposite side is x, the hypotenuse side is a. Then the adjacent side is the expression that you are substituting. Yeah or not? Okay, so can you do the same for x equals to a tangent theta? Okay, try and draw your triangle. What's the triangle of this? And then what's the triangle of secant theta? Let's try and draw these two triangles. I give you 1 minute to draw this. Let's try and draw the corresponding triangle. Okay, so let's compare. So if tangent theta equals to sine over a, what you get is opposite side is x, adjacent side is a. Okay, so the hypotenuse side is a squared plus x squared square root of it. So this is the expression you're gonna consider when you do this substitution here. And how about the last one? You draw this triangle theta, then cos is adjacent over hypotenuse, so adjacent is a, hypotenuse is x, so the opposite x is exactly the expression you consider. Okay or not? So why you want to do this kind of substitution? Because it fits to the right angle triangle. Okay, so that you can consider this. And then later I'll show you what's the advantage of matching this triangle here. it will make your substitution or your integral simpler. Okay, after you do this integration. Okay, so but there's some restriction here. So this is a restriction or a warning here. There's some give and take after you do this substitution, because when you try and write your x in terms of something else, then you are pretty much fixed by the new function. So what do I mean by fixed by a new function? So the region that you can take is smaller. Okay, because sine theta, right? Sine theta you can only restrict to a period. Okay, you cannot just take theta for the whole real line. Because otherwise, if you take substitution, right? If you imagine you want to substitute like x from some, let's say 0 to 1. If you take the sine theta to be the whole sine theta, right? So where can sine theta take value to 1? Pi, multiple of pi over 2. Okay, so which pi over 2 you want to take? This is the problem. Okay, so we fix such that there's only one appearing in that region. So such that it is kind of injective, okay, in one region. Okay, so for example, in negative pi to pi, right, you get something like this. Maybe let's use this color. Okay, like this. Okay, we don't want to repeat values. Okay, we don't want the part at the back. And then how about tangent x here? So tangent x is something like that. From negative pi over 2 to pi over 2. Okay. And then last one is the secant, or I just draw the cos picture. Okay, so the cos picture is like this. Okay. Such that for every value y, okay, there's one value x only. Okay, we don't want to like have two value x correspond to one value. So then the relevant identity is on the right hand side is what we have discussed just now. Okay, these are very useful after you do substitution. Can you imagine how you use it? Can you imagine or not? How you use it? So if you do substitution, what do you get for the first one? So if you really do substitution into your expression, what do you get? A square minus a square sine square theta. Okay, in this case here, what do you get? A square times 1 minus sine square theta. Okay, so you have combined 1 minus sine square theta into cos square theta. Okay, so square root of a square cos square theta. But you take a square root, right? So what do you get? You get a cos theta. Okay, so you simplify a square root expression to something simple. Right? So this is the idea of this trivial substitution. Does it make sense? So if there's a difference of square inside square root or sum, then you can relate to this triangle. If you cannot remember this triangle is enough. Right? This triangle will tell you how you substitute. Because depends on where these xa and square root terms appear inside the triangle. Does it make sense? Does it make sense? Okay. Can you look at this column of expression here? Straight away deduce this triangle. Can you do that? Can you find over where from this column to the last column here? Can you think of a way? Maybe you should think about the Pythagoras theorem, a square. So here the master formula I think you need to remember is master formula is a square plus b square equals to c square. Okay, so yeah, c a b like that. Okay. C square a square minus b square equals to c square. So how does the negative sign appear? It could be possible that you take c square minus b square like that. Okay. So maybe you can think of the first term inside the difference usually happen at the hypothesis. Okay, it happen at the hypothesis x and a, where the first one you take x square minus x square, and then the other one. So you can think of a and x and the hypotenuse. And then if you fix the hypotenuse, basically you fix everything else. Okay. So far. Okay, so far so good. Okay, so if you can remember how to go from expression to this triangle, then you will know how to do this substitution, because you just put your angle at this side. Okay, the opposite side of the right angle, vertical, the height. Okay, opposite the height of your right angle height. Then after that, this master identity is coming from sine square theta plus cos square theta equals to 1. So there's a second master formula here. Sine square theta plus cos square theta equals to 1. Okay. So actually, this second master formula, right, also come from the Pythagoras theorem. Did you realize? Actually, come from Pythagoras theorem as well. When c equals to 1. Okay, when c equals to 1, it's come from this. Okay, Pythagoras theorem. Okay, so everything just comes from Pythagoras theorem. You know where does the Pythagoras theorem come from? Why people want to look at Pythagoras theorem? You know why? Or do you know where it's from? Or where does Pythagoras live? Pythagoras. And where he live?
H3.
Greek. Egypt. Egypt. Pythagoras. Name. Why? Why is Pythagoras in China? Okay, so Pythagoras is in Egypt. Okay, so you know Egypt? Have you been to Egypt, or have you like watched any documentary about Egypt? I think you know about the Great Pyramid, right? Okay. Sorry? Triangle Tower, yes. Okay, so how can the pyramid like so precise? Okay. Definitely they use Pythagoras theorem. So they have to make sure their right angle triangle is really a right angle. The right angle they made is really right angle. Correct or not? How do you make sure it is a right angle? So you can measure the side. So it satisfies a square plus b square equals to c square. Okay. Another thing is in Egypt, right? There's a long river, just like China. There's a yellow river, right? In Egypt, it's the same. What's the name of the river? Nile. Nile, right? Okay. Nile. How to spell? N-I. How to spell? Anyone know how to spell? Maybe I should write down the name. N-I-L-E? No, A. N-I-L-E? Is it? Okay, please check. I'm not sure. But the pronounce is Nile. So they live around this Nile river, right? Okay. So they need to divide out the land. Okay. They need to divide out the land. So how do you divide the land just? So how do you equally divide it? Okay. So imagine you are ancient people, right? You take a ruler and then you measure the land. If it is not right angle triangle, what happens? Maybe you will give out more land, or you will give out less land, right? You should imagine this measurement in grade scale. It's not like this piece of paper like that. Okay, it's like a hectare, like as big as our university, right? Okay, so you need to make sure you have the right angle triangle so that you can compute your area equally. Correct or not? Okay, you need to make sure these are right. Okay, correct. For example. Okay, so then if you want to make sure this is right angle, then you can check the side, okay, whether they satisfy the Pythagoras theorem. Okay, so what I want to say is mathematics is really coming from practical use. Okay, they come from practical use. Okay, all right. So let's come back for this integration here. Okay, so this is a square minus x square. It's a constant minus the variable square. So what do? We use the first substitution here. Okay, so let x equals to a sine theta such that dx equals to a cos theta d theta. So let's do this first, and then we will see what else we need. So like what we just discussed, these were basically simplify our substitution. Okay, but at the expense of producing some extra function, we can get rid of it later. Should I think it's better I do it one step by step? Okay, so we use the famous formula to reduce this to cos square theta. Okay, but in the end, we still produce cos square theta here. So just now we decided that we can make this into a double angle formula. I hope I didn't use the wrong one. Is it 1 plus cos 2 theta over 2? Is this right? Can you check this double angle formula? Yeah. Okay, if this is right, then we again use substitution on 2 theta. So what's the substitution you're gonna do? V equals to 2 theta, dv equals to 2 d theta. So that we get so for the first one is 1 over half d theta, this one no worries. But the second one, what do we get? We get 1 over 2 of cos v over 2 again, so dv. Okay, so let's pull the 2 out, then we get theta plus cos, so we get sine v over 2 plus, let's say, some constant e here. And then if we put everything together, we get theta plus half of sine 2 theta plus, let's say, plus c. But note that our integral is in terms of x, right? But this is in terms of theta. So how to go from theta to x? So we need to go all the way back here. Okay, how to go from theta to x? Okay, so theta here actually is equals to sine inverse of x over x. Okay, so we substitute back your x in terms of x. So this is a squared over 2 sine inverse x over a plus half of sine of 2 times the sine inverse of x over a. Let's see. Okay, so this is the final answer. Okay. Any questions so far? Any questions? So we have combined the use of the trigo substitution before. Trigo identity, I mean. Okay, any question? Or any part you want to zoom in? See? Okay, if no question, we'll continue. How about this? Maybe I'll let you try for 1 minute. This question is not long, but let's try it. See how much you get. Okay, so this is a 9 plus x squared, right? So 9 is some square. It's a square of 3. Okay, so sorry. Yeah, which one do you want to use? Maybe tangent x equals to a tangent x, tangent theta. Okay, so we will do that. So in this case here, we'll use x equals to 3 tangent theta. So such that dx is 3 secant squared theta d theta. Okay, so then in this case here, what do we get? We get 3 secant squared theta over square root 9 plus 9 tangent squared. Okay, and then we get 3 secant squared theta over. So we can combine 1 plus tangent squared theta. So there's a rule we use here. 1 plus tangent squared theta equals to secant squared theta. It will become 9 secant squared theta. So altogether we get just secant theta d theta. So how do we do this integration? This integration actually is quite hard because this is what we did before. This is ln secant theta plus tangent theta plus c. So this is the example 5.42. This is what we did before. Okay, you can check it out. Okay, otherwise you can repeat it again. Okay, it's not trivial, but it's doable. But this is in terms of theta, right? We need to put it back to x. Okay, so to put it back to x, so you need to check using this substitution. So theta will become tangent inverse of 3 of x over 3 like that. Okay, so you substitute everything back. You get secant of tangent inverse s over 3 plus, so tangent on tangent inverse become x over 3, okay, plus c like that. Okay, so far so good. Any question? Question? Okay. All right. Should we continue to do the rest? Let me see which one is more interesting. Okay, maybe we'll skip 7.21. So this is obviously another example. This is x squared minus 4, right? You should use the third substitution. Okay, so let's skip this one. So this one, maybe tell me what to substitute. Then we can skip. Okay, looking at this, what do you want to substitute? X equals to what? So x squared minus a squared, right? So a here is 2, right? So x equals to 2 times second. Yes. Okay, do this. But this one is a definite integral, huh? So you need to check when x equals to 4, when x equals to 2, what's your angle? Okay, so maybe let's quickly check. So secant theta becomes 2, secant theta becomes 1 because you need to divide by 2. So this means that actually maybe cos is easy to remember or you have memorized before. Okay, but not that in your cos function, right? There are few places you can get half. But the problem is we only fix our theta in between 0 and pi. So there's only one value you're gonna get. Okay, you cannot get more than one value. And please don't choose in the wrong um, interval. Okay, we just fix to pi. Okay, so you need to pick everything between 0 and pi. Okay, don't pick beyond pi. Okay, or not? Does it make sense? Okay, unless you shift your interval, right? Either you want to pick from 0 to pi, or maybe you pick pi to 2 pi. Okay, but you cannot mix. Okay, mix up the one to one relation. Okay, please don't mix up. Okay, we only fix the region from 0 to pi. So this part here become very important. This domain here. Okay. There are a lot of one-to-one domain, but don't pick a different one-to-one domain here. Does it make sense? Okay. Any question? Okay. All right. If no question, let's go to the next one. It's more challenging. This one is more challenging. How about look at this? I give you 1 minute. See what you can do with this. This is not like the obvious x squared minus a squared, but can you turn it into something that looks like that? Meaning sum of square. Huh? X plus 1, right? Okay, so you do factorization actually. Okay, so if you look at it long enough, you realize that there is a quadratic function inside here that you can factorize. Okay, because x squared plus 2x plus 1 is actually x plus 1 squared. Okay, so instead of x squared, the variable become x plus 1. Okay, so in this case here, you will let x plus 1 equals to 5 tangent x. And then you continue. Okay, and then you continue from here. Okay, good. So far, so good. Okay, let's see next one, challenging or not. Next one is similar, I guess. This is x squared plus 4. So what you do, you use the x equals to 2 tangent theta. Okay, and then you do the rest. Okay, this one quite obvious, kind of obvious. And then how about next one? How about this one? What's the substitution you want to do here? I mean, this one is obvious, but maybe you will ask why this question pop up. Because this square root x squared minus a squared here appear in the denominator. Okay, so meaning there's some extra work you need to do here. Okay, extra work you need to do. But it's not too hard as well. Okay, but the substitution is just the same. X equals to a secant theta. Okay. How about this one? This one a bit different. What do you think? What kind of substitution you want to do here? Is there any sum of square? Okay, any sum of square here? Can you see any sum of square inside here? 2x square, good. Plus 3 square. Okay, good. Yeah. So this is the substitution you're going to see here. So actually, you need to set 2x equals to 3 tangent theta. Okay. Because you're going to see this integral here as 4x squared is 9, 3 over 2 dx, which is s cubed over 2x square, everything square plus 3 square. Like that. Okay, and then you do substitution. So this is the definite integral. So again, you need to like change your limit. So when x equals 0, what's your tangent theta? And then when x equals to 3 square root 3 over 2, what is your tangent theta? And then you're going to solve your theta. Okay, going to solve your theta. So again, here when you're solving your theta, you need to be careful with your domain. Okay, which domain we pick? Which is the one-to-one domain that we pick? Because if you just look at the whole tangent theta, the value of y will repeat because it's a periodic function, right? Okay, so we just pick one of the period. So the period we pick here is negative pi over 2 to pi over 2. Okay. So fix one of the one-to-one domain, okay, to calculate. Okay. Make sense? Yeah, because tangent theta is like repeating, so you will have a lot of 0 popping up, a lot of pi over 3 popping up. So you need to fix to one of the one-to-one domain to compute. Otherwise, you will jump your function. Then your integral will be calculating extra stuff. Okay, so make sure you fix to a one-to-one domain here. Okay, fix to a one-to-one domain. If you jump, right, then maybe you calculate extra domain, correct or not? Okay, so make sure you don't jump your one-to-one domain. Okay, otherwise you'll calculate extra. Okay, so far so good. Okay, so far. Yeah, so just follow this and then do your substitution rule and then compute. Maybe one more before we take a break. One more here. How about this one? Can you see any sum of square popping up? 4? What? 4 minus? What? Why you want to try? Can you see any sum of square here? X plus 1. Again, x plus 1. Okay, so perhaps what we do here is we could add one of the 1 inside there, or minus 1 actually. Okay, and then we can factorize it. 4 minus x plus 1 squared like that. Okay, so in this case here, you will let x plus 1 to be the new variable. And then this is the sine substitution, so 2 sine theta. And then you do the calculation. Okay, so far, any questions so far? So far, so good. Okay, please continue the calculation. And then the calculation you should continue is like whatever we did for the previous section. Okay, it will involve some of the section before. Any question before we break? Hey, it's better that you ask in front of the class instead of you come here and ask me. Because why? You can help your friend also. Right? You can help your friend because your friend also stuck. So we can discuss together. Is it okay? Can we create this kind of culture in SMUM? Create this kind of discussion culture here. Because one day you will go into club as well. So you are the club president, or you are the club treasurer, you are the club secretary, or even you need to do your CS, right? Community service. You will be the project leader, or the project secretary, or the project treasurer, right? So hopefully you can keep this kind of communication, okay, within yourself. Does it make sense? Don't keep things inside yourself, because nobody can understand you one. Okay, you need to voice out. Okay, and then discuss. Okay, so let's take a break from here. Let's break until 11:06. And I'll continue with my group. Okay, Jia Chen. Yeah, do you have group? Who? Two of you? Only? Okay. So Jia Chen. Sorry? For now too. Then I don't confirm you first. Only when you confirm, then I will count you. You can go and find others if you like. Okay, yeah. Fix it by next week. Jia Yi. Jia Yi. Do you have a group with who? Confirm. Xingyue. Xingyue. Wait. So Xingyue. Xingyue. Lu Xingyue. Yep. And who else? Xiangsi. Okay, Xiangsi. Any more? With you? Okay. Yeah, except you. Okay. So, Ping Zhen, right? Okay, good. Okay, who? Qijing? Huang Qijing, ne? Okay. Did you have group yet? Not yet. Okay, please find it. Confirm by next week. Yiqing. Yiqing. Where is Yiqing? You, right? Okay. Do you have group? No? Please find a group. Okay. Jia Tan. How about you? Who? Who? 026. Xingyang. Where is Xingyang? Okay. So you fix R3 only. 21, 25, 26. Okay, good. 21, 25, 26. Okay, 25, 21. Wait, 25 and what? Oh, you mean, okay, sorry. You mean the ID 21, 25, 26. Got Xingyang. Okay. Hao Yun. Okay, have you found a group? Liu Hansen. Where is it? Han Xiang. Two only. Only two. Okay. Okay, good. So Han Xiang. Han Xiang, that one, right? 10. Group 10. Okay, Wen Qi. Wen Qi, do you have a group? Who? Gu Wanda. And then Ma Yipian. Only three. Fix. Okay. So 11. So your group 11. Ma Yipian. Yu Heng still discussing. Okay. Then more people. Chong Yi. Chong Yi, do you have group? Not yet. Are you finding group? Yeah, please go and find a group. Ying Jie. Okay, you? No group. He also no group. Maybe can talk with Chong Yi. Yeah, you two can talk. See whether can be together or not. Gopagani. Gopagani. Have you found group yet? No? Yeah, please talk to each other. Arthur here or not? Yeah, Arthur, do you have group? You have group already? Okay, who is in your group? Madia, Daniel, and Hisham. Okay. Madia. Hisham is the front man. Okay. Hisham. So you are group 12. So Arthur, Hisham, Daniel, Madia. Okay, good. Group 12, huh? Jose, you found your group? 3, fix. Okay. So Aaron, so group 13. Aaron, Alicia. Okay, good. Hashim. Hashim? Is Hashim here or not? Hashim not here. Okay. Gunakanti here or not? Okay. Have you found group? Not yet. Are you finding? So maybe you can fix by next week. Okay. Gunakanti. Javed here or not? Javed not here. Gabriel is the front one. Gabriel is the okay. Have you found groups? Who? Gabriel, Pretty, Jeffrey. Fix. Huh? 3 of you. Which one more is who? Hashif is Javed, huh? Oh, okay. So he already talked to you guys. Okay. So you are group 14. Okay. Okay, once you fix your group leader, and then fix your topics. Okay, by next week. And then for those who haven't found your group, find your group. If you can fix your topics as well, fix it by next week. Okay, because you really have only 3 weeks more, 4 weeks, 3 weeks to work out. Okay, so you need to catch up. Photo, small photo.
No, I don't think I can catch up the speed on the class.
Okay.
And make me feel like a little bit. Yes. Little question about when for this question, I prefer to solve them right after the class. If I wait until you upload them on Moodle, I already forgot what question I meant on the class.
Yeah. Usually I was quite fast uploading after the lecture.
Normally, I know how to into this step.
Yeah.
But it's hard for me to finish the calculation. I always made many.
Mistake.
Yes.
Okay, I think that one is natural. This one is normal. You just have to do more.
Not mistakes.
Not mistakes.
But if I know just do the simplify and then I stuck.
You start.
I don't know what's the next step.
Oh, then that's the thing that we did in the previous chapter, this chapter. After your substitution, it will come back to this kind of thing. Come to this kind of question. So maybe you need to do more this kind of question. Yeah, practice this kind of question. Because for this part, it's just getting you from polynomial to trig. Then after going into trig, you should do the previous thing. Yeah. Okay. And then sometimes you need to realize some of the integral that we already solved. Then you can directly use. Okay, before we leave this trigger substitution, maybe one thing I want you to realize, this is another thing that Howran that mentioned to me last time. That is, if you realize when we do substitution, right? Maybe if you look at this, you will do like, for example, y equals to u equals to a squared minus x squared, and then du equals to minus 2x dx like that, right? But then you realize that if you do this substitution, you get like square root u, and then you cannot make your x disappear, right? You cannot make your x disappear because there's a derivative that comes out here. Okay, so instead we teach you a way. Okay, instead this is not good because x still appear after substitution. So we provide a substitution. We provide a new approach. Instead, do trigger substitution. Okay. So the problem with trigger substitution is you make your x equals to something else. Okay. So what's the thing that you want to use here? Maybe I demonstrate a full step without looking at the table. So if I make a here, x here, because just now we say that the first term of the difference, we should regard it as a hypotenuse, so that we really get this one of the side length is a squared minus x squared square root of it. Then what's the x we can substitute here? So a very convenient one is to take just x and a. Instead of taking the side of square root, we take x and a. So how to take x and a? What kind of angle you can take x and a? Opposite and hypotenuse. So opposite and hypotenuse can form what? Cos, right? Okay, so cos, so the relation is cos theta equals to opposite of hypotenuse is sine. Yeah, so sine theta is equals to x over a. So you can substitute your x to be a sine theta. Okay, so this matches with your tables, right? Does this match with your table? So look back your table. See, a squared minus x squared square root is using sine theta here. Okay or not? Okay. So what has been done here is you change the hard side of your triangle into two of the simpler side of the triangle. Okay. But you see, what's the difference between here and u substitution and x substitution? So x substitution turn x into another function. The u substitution is you combine the function, just combine the function. So actually you are using the same function, doesn't change. But here it changed. So that's why we need to have a restriction on the domain. Okay, that's why we have a restriction on the domain. Does it make sense or not? Okay. So because this one, you write it in terms of some function in theta. Previously, you were just combining the function in x. Okay, so this is the difference. Okay, how run? This is what you have been talking with me last time. Yeah. Okay or not? Okay. So that's why there's a restriction on your domain here. Restriction domain. Okay. Or make sure it is 1-to-1. Okay, 1-to-1 is important. Okay, because sine theta is periodic. Okay, so there's several x value that can send to the same value of y. So we just want to pick one. Okay. So what's the region that we fix for sine theta? Is from negative pi over 2 to pi over 2. Okay, like that. Okay, so this is the 1-to-1 domain here. Okay, make sense? Does it make sense? Any question so far? Okay, good. So we turn a polynomial function or the square root function of polynomial into a polynomial in trigonometry. So you need to go to the previous section, okay, to do exercise, this kind of question, okay. So pretty much the technicalities lies inside here, okay, how to integrate a trigo function, okay. Can you use substitution or not? I mean, can you use substitution rule, or you need to use a bunch of trigo identity first before you use substitution? Okay. And then what trigo identity to use? Okay, it's very important. Yeah, so if you are not familiar, you should do some exercise. Okay, I'm not saying that after you do a lot of exercise, you will know how to do, but make sure every time when you do exercise, make sure you figure out why this works. And then this will help you to predict the next one. Okay, it's not just looking at that question and then I memorize. I know what to do again when this question comes up. It is to realize that what works and what don't works. Okay, this will help you to predict the new example. Okay or not? Okay. Then we'll go to the next section. Okay, next section, which is the integral of rational function. And then finally, we'll learn something called partial fractions. Okay. So in this chapter here, we will just deal with the portion of polynomial. Okay, so which is the rational function. All right. Let's look at the first one. Okay, so what do you reckon? What can you do in the first one? First one is quite easy. Okay, you know how to integrate polynomial, right? Can you make this into a polynomial? Okay. So the x plus 1, what can you do with it? Huh? Malaysia. Huh? Become -3. Oh, you mean, okay, I get what you mean. So you say you just write it as a polynomial in term of negative degree. Okay, this is easier to see, right? Okay, but then what can you do? Then stuck. Huh? What can you do next? Huh? You look at the answer already. It's okay, but what should you do? You know the answer? Oh, I mean like there's a +1 inside there, right? What's the way that help you to remove the +1? You can use the substitution. right? So if you substitute u equals to x plus y, du equals to dx, okay, then this whole thing will become 2 times u to the minus 3 du. Okay, so use substitution rule. Okay, then what do you get? Minus, or 2 over minus 2 u to the 2 plus c, okay, which is minus 1 over x plus 1 square plus, okay, yeah. Substitution rule. Okay. Okay, how about next one? So you see that there's x cubed plus x over x minus 1, right? So there are x appearing on two terms here. So one way we could simplify it is to factorize it. Let's see if we can get something easier. Huh? Okay. Then anything we can do here? What do you think? I mean, the idea is the denominator, we need to simplify it, right? I think we cannot cancel out, right? There's no factor for you to cancel here. Unless it's x squared minus 1. So you can split to x plus 1, x minus 1, and then cancel out. But here is x squared plus 1. So can we simplify this? Any way to simplify this? Here we can kind of translate your x again. So it's like substitution again. So this time we don't substitute x squared plus 1. We substitute x minus 1. Okay, so that x will become u plus 1. Okay, then what's your du? du equals to dx. So very simple, du just transform to dx. It's just translation. Then what do you get? U plus 1 times u plus 1 square plus 1 over u plus 1 minus 1 is u. And then du. Like that. Okay, so everything become polynomial in u. In this case here, it's easy to see how to cancel because x minus 1 surely cannot cancel with x. But now there's a bunch of u and then over u, so you just cancel with u. Okay, so what do we get here? Let's compute the large portion here. U cubed plus 2u squared plus 2u plus u squared plus 2u plus 2. Maybe you can check my answer. Okay, so what do we get here? Integrating u squared plus 3u plus 4 plus 2 over u du. So you just have polynomial and then you have 2 over u. Okay, so integrate every terms here. Any term that you don't know how to integrate or not. So you get u cubed over 3 plus 3 over 2 u squared plus 4u plus 2 times ln of absolute u plus c. Okay, so this is in terms of u, but your question is in terms of x. So make sure you put your x back. Okay, substitute back your x. So your u is x minus 1 cubed over 3. It's 3 over 2 times x minus 1 squared plus 4 times x minus 1 minus 2 times ln of x minus 1. Absolute value plus c. That's it. Okay, so far. Can follow? Okay. Okay, if you can follow this one, how about do the next one? Okay, how about do this one? Is there a way to simplify 2x plus 2 over x squared minus 4x plus 8? There's some factor appearing, right? 2, for example. How about the denominator? Is there any way to simplify it? Actually, myself also haven't finished compute this answer. Should we try together? Well, this one comes to. For the denominator, this is what I choose to do. Not sure, is this what you'll try to do? This is the way I factorize it. What's the best way to continue here? I mean, one way to simplify is maybe I can let y equals to x minus 2 and then dy equals to dx, such that I'll get y plus 3 in the numerator, and then denominator get x squared plus 4. Surely one side is easier to compute because the derivative and the function is appearing together. But I'm not sure whether the other one is easy to compute or not. Okay, so anyone realize the first one can use substitution rule? First one can use substitution rule. So if you set u equals to y squared plus 4, du equals to 2y dy. Okay, so the first one, you can use substitution rule, which is du over u. Okay, this one is good. How about the second one? Do we use the trigo stuff? Because there's an a squared minus plus 4 plus 4, right? Can we use that? Can we use that? Is it helpful here? Or can we? Substitution doesn't work, right? What else we learn? Only trigo, huh? Because you can see these as 6. Can we do by part? We do by part. Is by part scary or not? Kind of scary. Because there's a y squared plus 4 down there. Okay, I don't want to integrate that. Do you want to differentiate that? Kind of scary. Okay, how about try the trigo just now? So maybe we can view it as this. Right. Okay, so for the first one, I think it's obvious already. It's just ln u. Let's try the trigo. So this is xy squared plus a squared, right? So what is it? So look at the table. We're gonna use tangent. Okay, let's use x equals to a tangent. By the way, I haven't do this question yet, so we will experience together. So y equals to 2 tangent theta. Okay, so what's our derivative then? So dy equals to, let me say a cheat. So d tangent theta, what is it? D tangent theta is 2 secant square theta. Okay, let's try this. Hopefully we can get something out of it. Otherwise we are done. We are doomed. 6 times 2 secant square theta. D theta. Okay, how about the bottom? So the bottom part become 2 tangent theta square plus 4. Everything to the square. Okay. So ln u, can we put the u back? I think we are okay to put the u back. Hey, what's our u? Our u is y square plus 4. Okay. And then this, what is this? So 12 of secant square theta d theta over, what's the bottom here? Okay, so the bottom here become 4 tangent square theta. How about, let's write it down. 4 tangent square theta plus 4. So this is 4 times tangent square theta plus 1. But what's this? This is secant square theta. I hope I'm not wrong. Yep. Okay, good. So at the bottom here, we get square root of it, right? So it become 2 secant theta, everything square. Good. You just see nice stuff coming up. See or not? The top square secant here have something to cancel with the denominator. Okay, and then you're left with a very easy integral here. So y square, we still need to put it back to x, right? So y is x minus 2. So here is x minus 2 square plus 4. And then here we just left with 3. 3 only. Correct? No? 12 divided by 4 is 3. Okay, so what do we left with? So the first term here, we can put it back to what it is. So x squared minus 4x plus 8. And then this one is 3 theta plus c. But what is theta here? Okay, so we need to substitute back everything into x. So theta here is y 3 times tangent inverse of y over 2. Okay, but y is not x yet, right? So what is our y? Our y is x minus 2. Just x minus 2. So 3 times tangent inverse of x minus 2. Okay. Okay, so this is the final answer. Okay. So you can see that after integration, right, the denominator becomes log of something. And then you have a contribution from your x minus 2 using tangent. That's it. Okay. Is the calculation dry? Kind of dry, but you'll see some cancellation happening, which is kind of fun. Okay. Because I think actually there's no meaning for now if you just calculate this. Just trying to find the integral. I mean, what's the meaning here? If you differentiate this, you have to try to differentiate this. If you differentiate this, you should be able to get back your integral. This is what the integral means, right? Antiderivative. So if you differentiate the ln thing with the tangent thing, you should get back your rational function. You want to try yourself? You should try. Okay, yeah. Okay. Because they are inverse of each other. Okay. So if you differentiate the ln plus tangent inverse, right, you should get back this fraction here. Okay. All right. Should we continue? Let's continue. Is this useful or not? Let me see. This one is kind of trivial actually. This is kind of trivial. Okay. Maybe let's try and factorize this and then we will see what we should do. Can you quickly factorize this? I think this is quite obvious. Okay, so what you should do is first pull the 2 out. Right. And then how about the bottom? Can you recognize that you can factorize this polynomial? There are 2 roots. What are the roots? -3 and -1. Okay. So you can split into x plus 3 and x minus 1. Sorry, x plus 1. So the roots are negative. So you can see that there's 2 factor appearing. So then you're just left with 2 over x plus 3. So this is easy, right? You can substitute x plus 3. So become 2 over u, and then how to integrate 2 over u? Ln u. And so on. Okay, so far so good. Okay, good. So this is about rational function. Okay. Next part of rational function, we will use the method called partial fraction. Okay, partial fraction. Okay, for the rest, we will learn partial fraction. So meaning you will write the polynomial, the fraction into sum of fraction. Okay, sum of fraction. So here is case 1. So below is case 1. So what does case 1 means? The denominator, okay, denominator is a product of distinct. Okay, very important. This word distinct. It must be distinct. Distinct linear factor. Okay, so let's have a look here. So let's decompose 3x minus 1 over x squared minus x into, sorry, x squared minus x minus 6 into partial fractions and find the integral of it. Have we computed this example before? Oh, no. Okay, never mind. So what does it mean by partial fraction here? So this is a new technique you're going to learn. So what do you do is first write 3x minus 1 over x squared minus x minus 6. Okay, so we can split the denominator into the product of distinct linear factor here. So what's the linear factor that you have? X minus 3 and x plus 2. Okay, so why is it linear? Because degree 1. Okay? And then they are distinct because they are different roots. So then we'll let it to be a over x minus 3 plus b over x minus s plus 2. This is a bit like your fraction. Can you recognize? This is a bit like your fraction. I make the rational number. For example, like what is 2 over 3 plus, like, let's say 1 over 2, like that. Okay. Then you need to make your denominator the same, right? Before you add them up. So it becomes 4 plus 3 over 6, which is 7 over 6. So this is kind of working backward. I give you 7 over 6. Go and guess this 2 and 1. Go and calculate the 2 and 1. Okay, so this is working backward. Does it make sense or not? Okay, we try to split 7 over 6 into something over 3, something over 2. Okay, so this is the idea here. So how to do that? Okay, so how to do that? So here is the technique. Well, what you should do is you multiply your factor across such that you get a times x plus 2 plus b times x minus 3 equals to 3x minus 1. Okay, meaning you just multiply your denominator across. Okay, so what should I write here? So multiply the denominator x minus 3, x plus 2 on the left hand side and the right hand side. Okay, Okay, so from here, this is useful to get A and B. So what we should do here? So what's the technique? Well, what's the root of x plus 2? What's the root of x minus 1? If you substitute the root in, what happens? Okay, if you substitute minus 2, what happens? This term will disappear. You only left with something in B. So you can find B. Again, if you substitute the root of x minus 3, then the term involving B disappear. Then the rest left with in terms of A. Then you can find A. Okay, so this is what we should do. Okay, we should try some value of x. If you don't want to put, like, let's say, if you don't want to put minus 2 or 3, you can put other values. You can put x equal to 0, put x equal to 1. But then A and B will stay. A and B will stay, right? But if you can create two equations that are not linearly dependent to each other, then you can use your linear algebra to solve it. Okay, but here we will use the fact that we know what are the zero to simplify the calculation. Because this equation I have to hold for all x. It's true for all x. Don't pick some x that's stable, such that is your calculation. Okay, so what are the nice x we can pick here? So let's pick x equals to minus 2. Then we'll get 3 times minus 2 minus 1 equals to b times minus 2 minus 3. Again, because the extra term here already disappeared, right? In this case, we get b equals to, or before that, maybe we get negative 7 equals to b times negative 5, which is b equals to 7 over 5, like that. Okay, and then we will do the next one. When x equals to 3, okay, what we left is 3 times 3 minus 1 equals to a times 3 plus 2, which is a equals to 8 over 5, like that. Make sense? Okay, so if you put everything back, put your a and b back into the partial fraction. Okay, so hence we have successfully write 3x minus 1 over x squared minus x minus 6 equals to 8 over 5 times x minus 3 plus 7 over 5 times x plus 2 in the denominator, not the numerator, don't confuse. Okay, so our integral can split into the sum. Okay. Can you see what's the advantage of us making our fraction here into partial fraction? Can you see what's the advantage here? Can you see what's the advantage here? Felicia, what's the advantage here? Oh, okay, so 8 over 5 can pull out. But what's important here is, you see, you have to integrate some x in the numerator and then some square quadratic in the numerator. This is hard. But you turn it into something just 1 over some x minus 3. Do you know how to do this? Yes, ln of x minus 3. How to do that? Substitution. Okay, substitute u equal to x minus 3. Okay. Does it make sense? Okay, so you can use your substitution to get 8 over 5. So maybe I just write here substitution, 1 of substitution, which is 8 over 5 ln of x minus 3 plus 7 5 ln of x plus 2 like that. Okay, clear. So if you look at the right hand side, right, you cannot imagine it is something just in terms of ln with some factor. Okay, but if you can write it as a partial fraction, then this is clear. Okay or not? Does it make sense? Okay, any questions so far? How about I let you try one more exercise? I give you 2 minutes. Okay, try and write this denominator into linear factors. Okay, so there are 3 factors you need to consider here. So you're gonna set A, B, C. This question. Okay. Luckily, this question is still easier because if you substitute the 3 roots inside, you can easily compute it. If you try some textbook examples, maybe you cannot just use the root to get the answer, then you need to involve some linear algebra to come in here. You want to use the row reduction also can, or you just use the substitution. Because the calculation will not be so involved, so substitution still works. But linear algebra definitely want you to use reduce row echelon form. So it will be harder if you're gonna do substitution there. But for our calculus, most of the time substitution will work. Okay, so if you do this calculation, you will get something like B is 3/2, A is -1, C is -1. Okay, can verify this. Okay, so if you put all this thing into it, if you put everything, you will get integral of 1 integrating -1/x plus 3/2 times x minus 3 -1/2 x plus. Okay, so again, this is just 1 over some linear polynomial. Okay, you can use substitution. So you can use substitution. Then you will transform everything to ln in terms of ln. Okay. Yeah. Any questions so far? Any question? Any questions so far? Good. Follow. Okay, follow. Okay. So before we finish, still got 4 minutes. So let's consider a second case. Okay, so this is a second case. So second case is the denominator is actually a product of linear function again, but it is not distinct anymore, sum of which is repeated. Okay, so in this case, okay, what we will do is, instead of just looking at x minus 3, okay, I mean we can't write like this, right? Because this way of writing is stupid. Okay, this is stupid. Because if you're gonna write this, a and b can be combined. Okay, but what happened is there could be a contribution from b over x minus 3 squared. Okay, there would be a contribution here. Okay, does it make sense? Okay, so if you set this out, then you will try and compute a and b again, and then you will find out that a and b will be non-trivial. Okay, a and b will be non-trivial. So for example, when x equals to 3, b is 3, and then when x equals to 0, and then you will get that 0 equals to a minus 3 plus 3, which is equals to a is 1. Okay or not? So maybe you want to make sense of this. Maybe we could try and make sense of this. So x over x minus 3 squared equals to 1 over x minus 3 plus 3 over x minus 3 squared. Okay. So it's true that you can split this into these because it will satisfy x equals to 1 times x minus 3 plus 3. Okay. Okay, does it make sense? Okay. A lot of students, what happened is they forgot this b here. Okay. If you follow this method, if you forgot b, you can still get a1. You can still calculate a. But then it is not equal anymore. Okay, but then it is not equal anymore. So you need to realize that these two things is not equal. X over x minus 3 squared is not equal to 1 over x minus 3. Okay, these two is not equal. Because on the right hand side, it is x minus 3 over x minus 3 squared. So obviously x and x minus 3 is different. Okay. So if, I mean, this is a common mistake. Because they forgot cases, then student will forget to write the B part. But they still can get A. It is true. So make sure that after you calculate, right, make sure this equal sign here is really equal. Okay. If you forget B, then it is not equal anymore. Okay, so you can see that there's an extra minus 3. That's why this B is very important to get rid of this minus 3. So you plus the 3 back. Does it make sense? Okay. So that's why this B is very important to remove this minus 3 from the first term here. Okay or not? Can understand? Understand? Okay. So if you're scared you forgot A, B, or C, right? Whatever, right? Make sure when you expand it, you get the same thing. Okay. When you put the number back, you get the same left and right. If you forgot, then that means there's something else you need to answer. Then without looking at the B, you still can find the B, right? Because you just need to add the 3 back. Correct? Minus 3 plus 3, then you will get the answer. Does that make sense? Okay. Okay. I think almost time. So maybe next week we will resume from here again. Okay. Any question before we break? Okay, if no question, we'll see you on next week. By the way, next Monday is a quiz. There will be a quiz 3. Okay, please be ready. Next Monday. Okay, chapter 5 and chapter 6. Next Monday. Monday. We don't have class on Monday? Yeah. No, quiz is online. Online quiz. Yeah. Okay, yeah. Okay. Yeah. Yes. We need to begin from chapter 5. Yeah, I think so. Yes.
所以有红区在
啊？
没有红区在online。
online。什么叫 home quiz？ 什么叫 home quiz？home quiz 是
因为给我们24小时时间去做。
对啊，就是24小时的时间。
哦，
呀。